Hi, my name is Dwayne and I'm going to be going over the tutorial 10 portfolio. In this task we're given a transfer function which we plot on a root locus so that we can see where they are, and then from here we can work out where on the real axis it lies. And once we've got that, we can also work out the angle that the asymptote comes off the real axis. So we can see here for values of k, 1 and 2, we get a 90 and a 180 degrees, so it goes straight up and down. And then we can basically see from any point where the poles are outwards, you can choose a value of k that will meet certain criteria. So for question A, we need to find a k that will give us the fastest settling time with a 5% overshoot. So what we do is we solve for gamma using the overshoot equation, which we can roughly estimate to about 0.707, which is 45 degrees, and find our desired pole locations, which are going to be on this line. We just have to work out a value of k that makes that possible. So what we can do is we can plug our desired pole locations into this equation here, and then plugging our s in as our pole locations, we can get a gain of 2. So a k for 2 will give us our desired settling time, and our omega n will be equal to 2.12 after using this equation here, this right angle triangle equation. For task 2, we've got another transfer function. Here it's got 1, 0 and 2 poles. So as you can see, we've got our 2 poles here and our 0 over here. After using our equation to find the asymptote, we can see that the asymptote leaves at 14 and goes off in a 180 degree over this way. And then solving for sigma in the breakaway point equation, you can see we can choose a point on the line at negative 29.5. That'll give us an overdamped system, but it's still possible. And then solving for k, we get 58. And then what is the steady state? So we can just plug it into our steady state equation, make s equal to 0, which gives us a high number of 1740. And if we plug that into our error calculation for our steady state, we get a value that's really small, which is close enough to 0. And that has a damping ratio of 1 because it's only on the real axis. Thank you.